Okay, this is LUX Ingester and EventParser training. My name is Nick Stroh. I'm a developer with ICG. I'm going to walk you through how to use our Plugin Development Kit, or PDK, to develop ingester and EventParser components for LUX. So we have a few slides to go through, and then we're going to go right into live coding using Eclipse. And you can follow along with the video. The PDK is freely available even without a LUX license. So this is an overview of what the user interface of LUX looks like to an end user. There's three main components to the screen. On the left-hand side, these are the list of rules that are running in this project, probably created by the user who's logged in, maybe other users that they are collaborating with. These rules you can think of as standing queries that use Boolean logic against the live data streams that are flowing through LUX, and they have a bunch of match criteria established. And when the events match the rules, an alert is created. And in the center panel here is one way to view your alerts, which is a geospatial view. So we have a map here and a number of push pins on the map, which are the alerts that are fired in the specified time frame, which you can also adjust. You see there's a heat map overlay that's being produced by one of the analytic components in the pipeline. So this is what the user interface looks like to the end user, but what we're going to be focused on today is really the back end of LUX, which is essentially a real-time data processing pipeline. So each of these components here, you can see there are a number of steps in the pipeline, and some of them have these plug icons in them indicating that they're able to accept plugins, and we can develop all of those using the PDK. So starting from the left, we have data coming in from a variety of sources in a variety of formats. And that data is all brought in to the ingest component using plugins. And this is where we will be focusing today. This is where both ingesters and event parsers live. A brief overview of the rest of the pipeline. The ingested data that is then formatted into LUX format will go on to an enrichment step. And the enrichment step really is to add metadata to the events and reformat it a little bit to make the end user's life a little easier. So for example, you have an IP address in your raw data feed. You can break that IP address apart into, city, state, country, zip code using geospatial lookups just to make, enable your end users to write rules such as show me all the network traffic in Maryland or in Baltimore, rather than having to use subnet ranges and things like that. After the data is enriched, it goes on to an analysis step, and these are where analytic plugins live, and analytics do complex correlations across time and space, looking for things like entities who are co-traveling or really complicated associations that are really difficult or impossible to do using just rules that end users write. So the end users are writing their rules up here, and if you follow this blue arrow down, the rules end up in this matching component, and that's really the complex event processor engine piece, and the rules are matched against these real-time data streams, and that's where you get your alerts. And so the alert component is also pluggable, so the alerts will go back to the dashboard. The alerts can go to email addresses. They can go to flat files, and you can write plugins to send them to various third-party systems. So I've been talking about ingesters and event parsers as two separate entities. It's a framework that we've created, and I just wanted to go over the distinction between the two. So the first is that ingesters are meant to connect to external data sources. So you can imagine just being a connector out to a file system or a network or a database, and just to bring in the raw data as it exists at that source. An event parser is then a component which kind of plugs into an ingester, which turns that raw data into LUX events. And this is so you don't have to reinvent the wheel every time you want to connect to the same data source. If, for example, you're connecting to Kafka, we have an ingester that connects to Kafka, and then you just have to write a parser if it's a format that we haven't seen before and don't have a parser for already. Now the third bullet says you can create ingesters to do both jobs if you want to. There's nothing in the API that will force you to write an event parser. That said, LUX ships out of the box with many ingesters already in place. So if you're connecting to, and you can see a list there, it's not an exhaustive list, but various message buses such as Kafka and JMS, email servers, file systems, FTP, a few databases are supported out of the box, TCP sockets, UDP sockets. We already have ingesters for all those written already, so all you'll have to write is an event parser. And so an event parser is a lighter weight API, even though they're both pretty lightweight, but there's even less to do in an event parser, which is good news as a developer. Also to note is that we have event parsers that also come out of the box and are as generic and configurable as we can make them. So if your data source is one that we already have an ingester for, and the format of the data is one that we've seen before, you don't have to write any code. So for example, we have the generic JSON event parser, which should be able to, through configuration, process any valid JSON that comes through the system. So again, for example, if you have your data on Kafka and it's in a JSON format, you shouldn't have to write any code. It should be all configuration to bring your data into LUX. So the workflow for using the plugin development kit, first is we want to create our plugins in Eclipse. Then we want to package those plugins into jars. Then we want to copy the jars out to various directories within LUX, which are created for the express purpose of loading specific plugins and their class paths. So if you create an event ingest plugin, there's an event ingest plugins folder that you should copy that to, and then the LUX framework will know how to load that and load the class path appropriately. After we've copied our jars out to the existing LUX installation, we'll then modify the configuration as needed to tell LUX to load those plugins. And then we can either restart LUX, or if you are in more of a production environment where you don't want to bring the system down at all, we have an administration console with command buttons on it to reload various parts of the infrastructure as the system is running. So if you create an event ingest plugin and you change the configuration files to load that plugin, you can go to the admin console, click reload ingesters, and it will pause the data flow, reload all those ingesters, and yours will be loaded. So this is what we're going to do in our live coding exercise, is we're going to actually just go through the plugin development lifecycle from start to finish. So I'm going to start with a blank Eclipse workspace. I'm going to bring in the PDK as it is distributed. We're going to create an ingester plugin. We're going to deploy that to LUX, watch it run. We'll see it in the admin console producing data. Then we'll do kind of a deeper dive into, again, ingesters versus event parsers. And we will look at a more realistic example that is already shipped with the PDK, and we'll maybe modify it a little bit. And then we can deploy that again and see it running in the admin console. So here we are in the live coding portion of this tutorial. So what I've done is just created a blank Eclipse workspace. And we're going to go ahead and get that set up for development. So on disk, I have the LUX PDK copied over, the gzipped version that is distributed, and we have an engine install ready to go here, which I understand some of you may not have to work with, but it is in the standard location user local LUX engine. So if you install LUX from the RPMs, this is where your engine will end up, and there are various directories under there and we'll explore some of them once we get to deploying our plugin. So the first thing we want to do is just extract our PDK. And what you'll end up with is a folder called PDK with a LUX PDK directory underneath it. And that LUX PDK directory is the folder that is ready to be loaded into Eclipse as a Java project. So we go to new Java project, uncheck the use default location, and just load it from where it is on disk. So that'll be, I've chosen to copy it to user local LUX PDK, but wherever you copied it to and extracted it. The only other thing you want to make sure that you do is that you want to be using a Java 8 JDK. From there we can click Finish, and that will load in as a Java project, and you'll have source and test directories with packages for each of the different types of plugins. So in the first part of the tutorial we talked about 4 out of the 5 of these plugin types. Just as a brief overview, there's also an event output plugin which enables you to fork enriched data out of the LUX pipeline off to, say, historical database or some other third-party system. So if you have the need to split the real-time data flow off for output elsewhere, you can write what's called an event output plugin. But for today, we're going to be focused on ingesters and event parsers. So you'll notice that there is a package under source for each of the different types of plugins, and then there's also a package under test for each of the different types of plugins. It's always good to unit test, but when you're doing plugin development, I would say it's critical to unit test because you're going to be deploying these plugins out to likely at least some sort of test system with other users. And the development methodology we use in plugin development is fail fast. So if something goes wrong on the initialization step of a plugin, we want to throw runtime exceptions, we want to crash and burn, because what we don't want is for things to look like they're working, but in reality data is not coming in, or data is being processed improperly, or data is being thrown on the floor, because then your end users are under the impression that they are monitoring data flows which they are not. And when you compromise the integrity of the system, that's usually a lot worse than just debugging something at the beginning of the pipeline. So we can go ahead and even we have my ingester, which is sort of just bare bones implement the API with a minimum number of lines of code ingester, and then we have this weather example which runs throughout the different plugin types. If you ever get around to looking at the different plugins, you'll notice that there's a weather example for each. And the weather plugins are more realistic representations of what plugins look like. So we can go ahead and even just run that unit test just to make sure everything looks good. So you will need, sorry I didn't mention it earlier, but you will need the JUnit Eclipse plugin if you want to run these unit tests, and I would encourage you to do so. So we can just right click on the weather ingest test and click run as JUnit test. And we can say the green bar means that all of our tests have passed. We have 3 tests in here. And if we look at the output, we can see that it's created 115 events, and it'll even print one out. And this JSON blob here, this is actually a LUX event that it has produced. And doing this is useful because you can make sure that the LUX event that you have created looks like what you intended to create, and any fields that may be missing, again, I would encourage you to put in the unit testing for the fields, but if not, you can at least get a visual on what may or may not be missing. So taking a look at my ingester, we can go through the API of an ingest plugin and really see that it's only a few functions. And you can tell that the functions with an override annotation are implementing the LUX Event Ingester API. So there's a load configuration function whose purpose in life is to give you the properties files that have been set in the configuration file associated with this plugin. So if we hop over to disk for a minute and take a look at the conf directory within the PDK, here's an example of an engine.properties file, which is the main configuration file which loads the engine. So for each type of plugin, you'll see that there's this configuration block, event.ingest.1, and there are a few properties. one of which is the class path, which will enable the LUX framework to load the main plugin class. And this again is an example of you put the jars in the right directory and they will be able to be loaded by the framework. Another configuration property is conf path, which will point toward a configuration file, which is then given to that plugin, which in this case happens to be the same file, engine.properties, but in practice you can make that any file you want and put it in the conf directory and it will be loaded. So typical properties file, key value, format, the properties will be populated and passed in. And what we can do here is we will load an example property. So we'll create a message string in our class, which we will output in our sample event. So in this MyIngester class, I'll show you the bare bones way to implement these functions, and then in Weather Ingester we'll do a little better job of error checking. So what I've done there is just loaded a property called message from the class into a string called message. The second function we have to implement is the start function. And the important thing to know about the start function is that this is where you want to start your threads and you want to return from this function. So this is indicating that plugins have loaded and it's time to start processing, but what you don't want to do is jump into a loop here and jump into an infinite loop to pull a database, because you need to return from this function. So we've created this function called send events, which is not part of the API, so I can call it whatever I want, but this is indicating that this is where we're actually going to send events. And so in start I will launch a new thread to call send events. So I've created a thread that will kick off and call send events, and it will also return from this function. And so in send events, this is where we actually want to send data through the pipeline. So you can see that there's a commented outline of code here, which is event listener.event received LUX event. And that is really the main purpose in life for an ingester, is there's an event listener that is waiting for the ingester to produce events. And the nice thing about ingesters is that there are no time constraints. So you can load data from your data source as quickly or as slowly as you want and send the data through as it is ready. When you get into enrichments and analytics, there are a lot of performance and concurrency concerns with keeping up with the data flows through the pipeline. But as an event ingester, you're at the front of the pipeline and you're not kind of beholden to any other plugin. So as fast as you can produce data is good, but there are no performance constraints to worry about. So what we'll do here is we will write a little block of code to send an event through every second, let's say. So we're creating a new LUX event object here, and we're going to have to go ahead and import this. So with the PDK, you have access to a number of common LUX libraries. So you have utility functions, you have obviously the VOs that you need, like LUX event, and LUX ships with a full copy of the Java doc. The PDK also ships with a PDF of instructions, and these examples also make use of a lot of common functionality. So hopefully through those three sources you can find what you're looking for within the common libraries, and if not, feel free to email support@icgsolutions.com for any other information. So a LUX event, again, as you saw in the JSON, was really just it's a number of key value pairs. There is some header information that we're going to want to set, like you want to give each event a unique identifier. So we can use UUID to do that. So every event we produce will have its own unique identifier using the UUID class. So there's an event date. Let's talk about the dates in the event for a second. There's an event date and there's a pub date. So event date is meant to be the date that the event actually occurred. So when typically a data source will have a timestamp for each event representing when the event occurred or when the observation occurred, and that's what you want to use for your event date. Pub date is intended to be the published date, which should be right now when we're creating the event. So we can just use new date for that. And for set event date, again, if this were a real example, we'd be using a timestamp from the event, and I think you'll see that in the weather example. But in this example, we will just use a date of 0, and we can import date. So again, what I've described are the way that we typically use the dates, but if your use case calls for something different and you want to make the event date the current time and the pub date something else, they're just date fields and you can use them for anything you like, really. So you see we have a number of fields here. We have a description, we have a title, we have geometries. Very few of these are required. I believe it's only event ID is something we have to create. Event date will default to the current time. There are defaults for a number of other of these fields. So we'll leave it at that for now. And I think there are some other examples in the weather example, and then should be completely documented in the Java doc. But what we do want to do is we want to add at least one attribute to this event, which is those key value pairs, which is really what users use most often to write rules. So what we'll do is we'll add a LUX attribute. And we'll have to import LUX attribute. And then we'll put our message in that LUX attribute. So this will give us a flat mapping from key to value. If you need nesting within your event, we do support one level of property nesting. So if, for example, your event contains 5 cars, and each car has a license plate and a VIN number and a color, and has a set of its own properties that you want to be able to keep grouped, you can add what are called LUX hits. And LUX hits are that grouping, and then we can add attributes to the hit itself through add hit attribute, which also just takes a LUX attribute. And then we can add that hit to the event. Okay, and then we can go ahead and send that event through the pipeline. So that block of code will create a LUX event every second and send it through for processing. And then the only other part of the pipeline is the stop function, in which, obviously if this were a real example, we would have kept track of our thread and started it and stopped it properly, and this is where we would shut down our threads. So that is actually a complete ingester. And in this example, we wouldn't even need an event parser because we are directly creating a LUX event and setting the fields, and it will be turned into the proper JSON format under the hood and sent through the pipeline. So what we can do is we can come over to our PDK, and you'll notice that there is a build script and a deploy script that come with the PDK. Now what the build script will do is it'll build each of those packages, each of the 5 packages, into its own jar file. So it's just an ant script that builds those 5 jar files ready to be deployed. The deploy script will copy those jar files off to the specified LUX installation directory into the appropriate folders, but it will also copy the conf directory. And this is important to understand because you may not want to overwrite the configuration of the LUX install with what's in your PDK. So I will show you how to manually copy over the jar files. In this example, I'm not using that engine install for anything else, so it would be fine if I just deployed it, but I'll show you how to copy over the jars. You can imagine a scenario where it's a production instance or there are other people changing the configuration and you don't want to just overwrite everything in the conf directory, because that does include, at least as when you unzip the PDK, that includes engine.properties, which is the main configuration file. So we will copy the my ingesters jar that we just created out to LUX. So again, my LUX instance is in the default location. So we will copy the my ingesters jar we just created out to LUX, and that's really it. Our plugin is now deployed, and then we just have to modify the engine.properties file and tell it to load that plugin. So in this example, we have event ingest 1, which is loading a weather ingester with a couple properties, presumably for that weather ingester. And then we have event ingest 2, which is loading my ingester, which we just created, and also passing in my engine.properties with a message of hi. So since we haven't even looked at the weather ingester yet, we can go ahead and just take this out. And this is actually what this file will look like. If you just ran that deploy script, you would copy the default PDK configuration out here, and it would look like this. So again, what we're saying is we're loading the myIngester class, and that's going to produce a stream of events. And we want to name each stream of events something unique. And this is so we can write rules on them and we can refer to them later throughout the pipeline and other plugins. So we'll just call it default stream. We can change this so that we will be able to recognize it on the admin console when it loads. And we just gave a message of hi. So we're now in the engine bin directory, and this is where there are various scripts to start and stop LUX. LUX may be installed in your system as a service, in which case you're going to be using service LUX engine stop and service LUX engine start. But if we bring up that admin console, so you can see my system is currently down, so that's what this red indicates. I haven't started it yet. The LUX Engine Administration Console is kind of a health and status page for LUX. So it has various collapsible sections here that actually represent the pipeline in order. So ingest, enrichment, analytics, matching, time correlation, which we won't talk about in this tutorial, circuit breaker, alert manager, and rule manager. A circuit breaker will turn off overactive rules that users create. And we've talked about the others. Rule manager is responsible for getting rules from the users and bringing them into the system. That's kind of off to the side of the main pipeline. So if we go ahead and start the engine, this is the log as it comes through, because I just started right in the main shell. And once this starts up, we can see that my ingester has started, and it's even started to send messages already. And we can see that we're getting EPS stands for events per second, APS is alerts per second. So we can say that it looks like it's running and producing data. And if we check in on the admin console and we expand event ingest, we can see that migrate ingester that we just configured is running, and it's producing 1 event per second. And the events are incrementing, and you'd expect that this graph will just stay a kind of a plateau as it goes. So this is good news. This looks like our first ingester was successfully created and deployed and is running in LUX. So we can go ahead and shut down the engine instance, and we'll take a look at a more complete ingester and event parser example in the weather parser. So jumping back into Eclipse, we can bring up the weather example and take a look at it. So weather ingester is the main class of this ingest plugin. So what we'll see right at the top is that we have some final static strings defined, and this is typically how we're going to define the keys that we'll pull out of the properties file. You can see we have our worker thread that we're going to keep track of. In this example, it's just a single thread, but depending on your data source needs, this may end up being a thread pool, like an executor service thread pool. And you may want to have a thread pool and a blocking queue and have the threads, work off the queue as needed, whatever current concurrency strategy you need, or it may be that one thread is fine for your needs. And then you can see here we have an event parser defined. This is a LUX event parser, and so it's clear that this is implementing the framework where the ingester is going to read the raw data, and then the LUX event parser is going to be responsible for taking that raw event data and turning it into a LUX event. So you can see our load configuration step is a little more involved because we're doing some error checking. So this is kind of better practice than we saw in the myIngester example. We're going to want to pull those properties out, by static key. And we're going to, this is using a utility function that is available in the LUX library. miscutil checked as empty, and all this is just a shorthand for make sure that the property is not null and make sure that there's not empty space or an empty string. And you can see, like I mentioned before, if a required property is not there, we want to just exit right away. We don't want the system to start up with a failed plugin or an improperly running plugin. And the next block here, we're loading a file. So this weather ingester, kind of big picture, is meant to read a weather RSS feed and process the RSS blocks and push them through as LUX events. We downloaded some of the RSS XML, and it ships with the PDK, and so that is actually what is being read, and it's this weatheralerts.xml file. So this is actually what's being parsed by the class. We didn't have it actually go out and reach the RSS feed for a variety of reasons, most of which there's no requirement on any external services to run. So this should always work for you. It doesn't need, you don't need an internet connection or anything like that. So you can see right here we are directly creating our event parser. So we're saying the event parser is weather event parser, which is also in this package. And you know, it's also being initialized with the same set of properties and the file manager from this class. The engine file manager is a convenience class for reading files off of disk, so it knows where the LUX data directories are, it knows where the conf directories are. You could just load files as normal by creating a file object and giving it a, you know, an absolute or relative path, but this is kind of a safer way to do it, because if you're not familiar with where your jar file is going to end up and you don't know where you're going to be on disk, you can use the file manager and get data file. So this may be a little confusing if you think about these ingesters being pluggable, as I mentioned, say our Kafka ingester being able to take whatever event parser class that you pass to it. It may be confusing to see this event parser directly created, because this would not allow for any event parser to be used with the weather ingester class. And if we wanted to make it a pluggable example, we would use another one of those functions from the libraries that come with the PDK, part of the LUX common libraries. And that's the LUX event parser factory. And that's all it takes. So this would be this is the way we would create this parser and make it pluggable to any event parser class. So this is how you're able to just create event parsers, put them in a jar file, put them in that event ingesters directory, and then use them with existing ingesters, because we use this factory function to dynamically load the jars when LUX is started. But for this example, we know what event parser we're going to use, so we can leave that directly created. So in the start function, we are starting the thread using plugin context thread factory new thread. So what this is going to do is this is going to create a named thread, and it's not very important to use this thread factory, but we recommend that you do, and you can also give your the threads that you create a name. And the purpose to using the name thread factory, got those parameters reversed. So the reason we might want to use a name thread factory is that in debugging, you can end up with a lot of running threads in a LUX instance, and it may be necessary, though not often necessary, to track down which of the threads is consuming resources, things like that. And so we usually create our threads with a name thread factory and give them all a unique name. Otherwise, by default, the class name is used as the name, and this will let you know if something's going wrong with a particular thread. Anyway, so we create our thread and then we kick it off and we keep a reference to it so that we can stop it later. And in our stop function, we are just going to go ahead and interrupt that thread. So the run function in this example is actually going to be that worker function that is we passed in as the runnable. And so that will be called when the thread starts. And this is going to, go into a loop and cycle through the input data. So In essence, these two lines of code are the real meat of what this ingester is doing. And so what they're doing is they're going to go ahead and read that file, that XML weather alerts file in, and pass it to the event parser. And they pass it in the form of an input stream. And they pass in the event listener, which is used to send the events on. So that is the implementation of the ingester interface. And so from there, we can hop into the event parser and see what that interface looks like. So LUX Event Parser is just saying, this is a class that knows how to take an input stream and turn it into a LUX event. And so the API, again, is just a few functions. Initialize will, in this case, take a properties file and the file manager. So that properties is going to be passed down, as we saw, starting at the configuration file. It's specified, the properties are loaded, those properties are passed to the ingester, and then the ingester will pass those same properties on to the event parser. So what you often end up with is configuration files that contain the ingester and the event parser properties together, because they're often, it's fairly often that the event parser doesn't take properties at all because it's a fixed data format, but sometimes you want to be flexible in your event parser, especially if it's something that's going to be distributed widely and used in a variety of contexts. Things like date formats often need to be flexible and configurable. And so in this initialize function, this is going to get into specifics of this format because we are in the event parser. And so, using document builder and building a DOM, this is XML specific stuff because this is a RSS XML format that we're parsing. But we are creating our document builder here from document builder factory. And so these two functions are what event parser is all about. So you have parse and dispatch events, and you have parse events. So that can be a little confusing. But really, what you have to understand is that sometimes these data sources are from, say, massive files, for example. And so you could have a data file that is several gigabytes. And so you can imagine taking a 5 gigabyte data file or a result set from a database that is, just a tremendous database pull, and you do not want to wait until the entire thing has been parsed before you send events through the pipeline, because you can't load all that data into memory, or it'll take too long and introduce too much lag for a number of different reasons. So parse and dispatch events are meant for cases where there are a large number of events per input stream. So the intention here is that as I go through that input stream, I'm sending the events, and you notice I'm returning void. So as I go through, I'm going to use that event listener that I've just been passed, and I'm just going to fire off events and return nothing. Parse events is for cases where the input stream is, one or two or a couple, whatever is reasonable for your case, events, and we're going to go ahead and parse that entire stream, put it into a list, and then return that list for sending. So this, the contract with this function is that it will send no events. It doesn't. That's why it doesn't have an event listener. And for this function, it will send the events, and that's why it gets the event listener. In practice, you can just override these both into the same function, right? If you're just going to use parse events, you don't see a case where, this is definitely the more rare case where you're getting these big blobs of data that you worry about memory and performance. So you can just override these both into the same function, which is what we're going to do here. So that's the entire API we've just discussed. And so from here, you're free to implement however you like. One recommendation is that, we roll these both into a single parse events function with a flag that says whether I should send during parsing or not. And if I do send during parsing, I'm going to send as I parse, and if not, I'm going to build up that list that I want to return and return it. So that's all this function is doing. So we declare our return list just in case we are returning. This is going to be XML specific. We're going to go ahead and iterate through our XML tree, and for each of our items in our tree, we're going to call weather event. So there's another class here, weather event, that knows how to parse an individual item in the DOM tree. There's a parsed LUX event here, which is the return value from parse events. And a parsed LUX event can be created just from a LUX event. So it is a wrapper that provides a few more options rather than just the LUX event that we created last time. It's not really important to understand the distinction between the two of them, especially to start with, because it is rare that you need to use them. So you can think of it just as a LUX event. But it provides you the ability to send events on different streams, and a couple other more advanced options. So that you can imagine if you want to take one event and send it on stream A and the next event on stream B, that could be, it's not entirely clear how to do that from within Ingester, but parse LUX event provides that functionality. But for our purposes, all I think we're going to be doing here is creating a LUX event. And so parse LUX event just has a dispatch function with the event listener, which is the exact same thing as just calling event listener.event received. In fact, you can even use that function if you want to send the event. And so we can hop into weather event just to see that LUX event being built. So again, we're parsing through the XML document and pulling out every element, and this weather event is being created from the element. So you can see create LUX event is really where it's happening, and the event is being created. We're going to set the event date based on the element publish date, which is the element in the XML. We're going to set the ID to, again, a random UUID. We set a publisher, set a source, and again, these are just header fields that are available to the end user in the form when they write their rules. So it may be useful in a particular use case to filter events by publisher, or by title, or by description, or by a number of these other header fields. And we're going to set the pub date to when we're creating it. And then this block is just iterating through the XML and looking for every tag in there and adding it as a flat element in the array. And this is a function to parse the date out from the format that's found in the XML using the simple date format defined up here. So if you ever need the LUX event date format, you can find it in LUX event.lux date format string, and this is the date format that is used throughout LUX as a standard. But if you need to add, obviously, if you need to add dates and other formats to your event, you're free to. So we can go ahead and run that unit test again, and we can see the LUX event that is produced. And so if we can go ahead and jump into that unit test, and we see that this is actually just doing a print of a printout of the event that is being produced. And so we can go ahead and try to modify that event as it's being created, and maybe set a field that hasn't been set before. So we can give it a description. say we looked at this header block before and we said, okay, I forgot my description, and my end users would like a description in there. You have some need for it, and when we run it again, we'll get that description in the header. So that's the weather ingester, and again, it's going to read that XML file and send out those events periodically. So let's go ahead and check how often it's going to send those events. So it looks like it's reading a property and cycle time seconds from one of those static strings, cycle time, weather alert ingest cycle time seconds, and that's going to be the number of seconds that it sleeps between sending all of the events in the file, which I think is 50 events or 100 events or something like that. So we can go ahead and build and deploy this ingester, and we can try to make both of these run side by side, the two ingesters that we've just worked on today. So if we just run that build script again, that's going to build all of the plugins in all those jars, and so in that my ingesters jar we'll end up with all of the classes that were in that package. So we'll get my ingester and we'll get the weather ingester and the parser. And so we can copy that out to LUX, to the LUX instance we have, the same way that we did before. And so now that's deployed, and so now all we want to do is modify that engine.properties file that we did last time to enable both of the plugins to run. Because we look at our admin console, nothing's running at the moment, and so let's go ahead and edit that. So this is the way our file looked last time, with only one event ingest plugin defined. So we can uncomment this section or add it if you don't have it. So when we're running multiple plugins, we will want them to have different numbers for the blocks, otherwise the last one will override the first. And we'll also want to separate our output from the plugins onto different streams. Now, when you write rules, when the end user writes rules, they will end up operating against a particular data stream. And typically, all data of the same type will end up on the same stream, or will be configured to run on the same stream. But if you have multiple plugins bringing in data that is the same format, so if we're getting weather data from disk and we're getting some weather data from RSS and we're getting some other from a database, and we want it all to be accessible on the same stream so that a user can just write a single rule against all that data, we could name these streams the same, and then all of that data would end up on the same stream and users could write rules against it. And also streams are used for enrichment plugins and analytic plugins to specify which data they should be processing. So for this example, since we have my ingester, which is just bringing in that message repeatedly, and then we have weather ingester, which is a completely different type of data, we'll put them on different data streams. We'll want to give them distinct names. So we have my weather ingester, and then my ingester. Change it back to my ingester. And then we have our properties. This is specifying the path to that XML file that will be read. We have our cycle time of 15 seconds. We can go ahead and crank that all the way up to 1 second, so that every second it's going to go ahead and parse that file. And so that should give us a pretty high data rate compared to our other 1 event per second. So we'll save that file and we'll hop into our engine directory, and we can start up LUX. And so what we expect to see here is both of the ingest plugins loading and a much higher data rate as the weather event is processed every second. So we can see that both of the plugins were loaded with the proper IDs, Weather Ingester and My Ingester. And you can see our data rate is over 100 per second, which sounds about right. So it looks like we had that 115 events in the file, plus the one from My Ingester. Okay, so that is the end of the LUX Ingester and EventParser training course. Don't hesitate to reach out with any questions or issues you may have. You can contact us at support@icgsolutions.com, and a reference to this course is TM1, that's Training Module 1. Thank you.